Welcome students, this is Ravi Shankar. See today, let us go on with the remaining questions, remaining book back one word questions. Let us go to the question number 9. So when you are considering that question number 9, question number 9 is given as an electric field. That electrical field given as E vector is equal to 10x I cap. Exist in a certain region of space, then the potential difference V is equal to, they have given the potential difference V is equal to V0 minus V, or it is given as V0 minus VA, where V0 is the potential at the origin. Here they have given where V0 is the potential at O, or we can say potential at the origin, and VA, they are considering VA as potential at x is equal to 2 meter. Potential at x is equal to 2 meter. What they have asked? See, an electrical field E is equal to 10xi. Along the x-axis, you are having an electrical field as 10xi. Exists in a certain region of space, then you are asked to calculate what is the potential difference. The potential difference is given as V0 minus VA, where V0 is the potential at the origin and VA is the potential at a distance of 2 meters. We have to calculate what is the potential difference. How we can able to calculate? See, we have studied a relationship between the electrical field and the potential difference as E is equal to minus of dV divided by dx. From this I can able to write the value of dV. What is this dV? dV can be written as minus of E into dx. I want to calculate V0 minus VA, V. So I am integrating this dV. On integrating this dV or by taking summation, I will be able to get V0 minus VA, which is considered to be the potential difference V, which is equal to, instead of this dV, I can write integral of minus of E into dx. Am I correct? When I am integrating, from where I am moving? From 0 to 2. That is when the potential difference is asked. You have to move the charge from, unit positive charge from one point to another point. So the difference is final minus initial. So the final point is considered to be 2 and the initial point is considered to be 0. Opposite to that of the electrical field. So what is the answer then? V0 minus VA is equal to, V is equal to minus of, what is the value? I can write integral of 2 to 0. Then minus of E is 10x of I cap into dx. You just integrate this equation to get the final answer. Come on, you know how to integrate? So we know that the value of V is equal to minus of, when 10x is integrated, 10 into, I can write x square divided by 2 within the limit 2 to 0. So what will be the answer? V is equal to minus of 10 into, or we can write 10 divided by 2 into upper limit. I can write 0 minus 4. So you will be getting minus of 5 multiplied it with minus of 4. So the potential difference is considered to be minus of minus will become plus 20 volt, or it is the work done in moving the unit positive charge. So in your book they have given it out as 20 joule. So V is equal to 20 joule. Then which one is the option? The option C is correct. It is considered in your book they have given it out as plus 20 joules. That is the answer. Then when you are going for the next one, question number 10, see, go through the question number 10. A thin conducting spherical shell of radius capital R has a charge Q which is uniformly distributed on its surface. The correct plot for the electrostatic potential due to this spherical shell is already we have studied. When you are considering a thin conducting spherical shell, and if you are having the charges q and the radius is r, what it is asked, the correct plot for the electrostatic potential due to the spherical surfaces. While studying that itself, we have drawn the graph by taking the radius or the distance along the x-axis and the potential along the y-axis. What will be the concept means? From origin till it reaches to what? Till it reaches to the surface, potential is 0. So from here to the point here, let us consider this as the radius r. Sorry, not 0, it is considered to be a constant. From 0 to, from the r center, not potential, potential is a constant. See, from the center point O to the surface, we can say the potential is considered to be a constant. So we can say the value of the potential is considered to be constant till it reaches the radius or till it reaches the surface. So if this is the center, the spherical shell can be drawn like this. So the spherical shell can be drawn like this. So we can say like this. This is considered to be the spherical shell, thin spherical shell. From center to the surface, we can say that the potential is considered to be constant, beyond which it decreases and reaches 0 as it moves away. If you are taking the point away from or out of the sphere, it is going on decreasing. V is inversely proportional to that of the r square. So option B is the correct option. So option B is the answer. This we are calling it out or considering it as question number 10. Similarly, let us move on to the next one. What is the next one? The next one is question number 11. 2 points A and B are maintained at a potential of 7 volt and minus 4 volt respectively. The work done in moving 50 electrons from the point A to the point B is dash. That is the question. So you are considering 2 points. At point A, the potential is 7 volt. So question number 11, you are saying at point A, the potential is considered to be 7 volt. Then they have given the point B. At point B, the potential is considered to be minus of 4 volt. The work done in moving 50 electrons. So let us take number of electrons is equal to 50. Charge of 1 electron is equal to minus of 1.6 into 10 to the power of minus 19 coulomb. Therefore, what is the total charge of the 50 electrons? It is 50 into or minus of 50 into 1.6 into 10 power minus 19 coulomb. You are asked to calculate the work done in moving. The work done in moving 50 electrons is nothing but the potential energy stored in the 50 electrons. So we can say work done in moving 50 electrons is equal to potential energy, which is equal to the potential difference multiplied it with what? Potential difference multiplied it with amount of charge moved. Is amount of charge moved. So what is the potential difference? The work done, we can say it out as work done or potential energy is equal to dV. What is dV? Final potential minus initial potential. Final potential is VB minus initial potential is VA. So VB minus VA multiplied it with the amount of charge moved, number of electrons, multiplied it with the charge of the electron. So what is VB? VB, I can write it out as minus 4 minus of 7 volt, multiplied it with number of electrons 50 into charge of 1 electron is minus of 1.6 into 10 to the power of minus 19. So multiply, you will be getting minus of 4 minus 7 is minus 11 into 50 into minus of minus will become plus. You get 1.6 into 10 to the power of minus 19. Multiply it, you will be getting 880 into 10 to the power of minus 19 joule, or you can write it out as 8.8 into 10 to the power of minus 17 joule. This was the answer given. So 8.80 into 10 power minus 17 joule. So answer is option A. This is the answer given. So the answer is option A as the answer. This is question number 11. Similarly, what is the question number 12? Consider. What is the question number 12? Say if voltage applied on a capacitor, if you are considering a voltage, and if that voltage is applied on the capacitor is increased from V to 2V, choose the correct conclusion. What are the given thing? Q remains the same, C is doubled, Q is doubled, C is doubled, C remains the same, Q is doubled, both Q and C remains same. See, already while studying the capacitor itself, I have told this, the capacitance is a constant. Capacitance is a constant, never changes with the charge or potential, or never changes with the charge. See, whenever there is an increase in charge, then there will be an increase in potential, or if there is an increase in potential, there will be an increase in charge. See, if the voltage applied on a capacitor is increased from original voltage is V, is increased to what? Is increased to 2V. What is the correct relation? You are asked to calculate what? You are asked to consider the correct relation or the correct statement given. See, we can say, when the voltage increases from V to 2V, then automatically the value of Q will be increased to what? The value of Q will be increased to 2Q. Since the value of Q is directly proportional to V. So, what happens? Charge gets doubled. Charge gets doubled. But what is the expression for capacitance? Capacitance is C is equal to Q divided by V. This is original. When it is increased, let us consider it as C dash. When the potential is increased to 2V, then automatically Q increased to 2Q. So again, you will be getting 2 will get cancelled. Again Q by V is C. So C dash will become C. Therefore, C remains constant. C remains constant. But what increases? But charge gets doubled. So option abdindrathu C. So C is the answer. Let us consider C as the answer, or option is C, where it was given as the charge remains doubled, or Q doubled, and C remains, the capacitance remains constant or same. Similarly, let us move on to the next question. What is the next question you see? A parallel plate capacitor stores a charge Q. Okay, a parallel plate capacitor stores a charge Q. Suppose the area of the parallel plate capacitor and the distance between the plates are each doubled, then which quantity that will change? So question number 13, a parallel plate capacitor. So when you are considering a parallel plate capacitor, the capacitance in general given by the formula epsilon 0 into A divided by D. General concept C is equal to Q by V. But if it is a parallel plate capacitor, capacitance C is equal to epsilon 0 into A divided by D. Since C is equal to epsilon 0 into A divided by D means, what will happen if area and distances are doubled? That was given. Suppose the area of the parallel plate capacitor and the distance between the plates each are doubled. So we can say area becomes 2A and D becomes 2D. Then the capacitance C dash is equal to epsilon 0 into 2A divided by 2D. Again this 2 will get cancelled, so you will get C. So C dash is equal to C. Capacitance remains the same. Okay. Capacitance remains same. Okay. Then what are the other things remaining same? So let us see. Capacitance remains the same. What are the other things? So capacitance remains the same means charge and voltage are also considered to be same. So the charge as well as the voltage are considered to be same. Then what is the fourth one? Odd man out. Odd man out is considered to be energy density. So energy density is the answer. Energy density is the answer, and which is considered to be the option D. Do you want how energy density is the answer? See, energy, we know that energy density is given by the formula epsilon E is equal to energy per unit volume. Energy density is nothing but energy per unit volume is equal to half into epsilon 0 into A into D multiplied it with E square. This is the formula that we have derived for energy density. See, when area, from this we can say energy density epsilon E is directly proportional to area and distance. When area and distances are changed, energy density will also change, or we can say if both are doubled, energy density will be 4 times. So we are saying that by increasing the area and the distance between the two plates, what increases? The energy density of the parallel plate capacitor increases. So in the given answer, fourth option, the option D is considered to be correct. Then what is the next one? Next one is an important problem. Question number 14. What is this question number 14? You see, 3 capacitors are connected in the form of a triangle as shown in the figure. The equivalent capacitance between the points A and C is asked. See, 3 capacitors. One of the capacitor is here, another capacitor is connected here, and another capacitor connected here. So all the 3 capacitors are connected in the form of a triangle, and this capacitor is having a value of 2 microfarad. This one having a value of 2 microfarad. And this one having a value of 1 microfarad. So we are having 3 capacitors connected in the form of a triangle, and this is A, and this point is B, and this point is C. What it is asked? You are asked to calculate equivalent capacitance across what? Across AC. So if you want to calculate the equivalent capacitance across AC, we can draw the diagram, equivalent diagram. See, these two are in series with the parallel. So I can draw like this. This is one capacitor, this one capacitor. These two capacitors are in series. And these capacitances are in parallel with that of what? Parallel with that of this third capacitor. So this is the equivalent diagram for this. If it is between A and C. This point we are considering it as A, and this point I am taking it as C. If I have to calculate the equivalent capacitance between A and B means these two are in series and this is in parallel with a combination. So across BC means these two are in series and this one is parallel. Here it was given, or it was asked, what is the equivalent capacitance between A and C? So these two capacitors are considered to be in series, and the other one is in parallel. So this 2 microfarad and this 2 microfarad are in series, and this is parallel. So let us calculate the combination of this. What is the combination? In series combination, we can write 1 by CS is equal to 1 by C1 plus 1 by C2. So you can get 1 by Cs is equal to 1. Taking reciprocal, Cs is equal to 1 microfarad. So then what is the equivalent capacitance for this? These two capacitors can be replaced by a single capacitor. This is 1 microfarad. And again you are having another capacitor at the bottom. And that value is also equal to 1 microfarad. Then what is the effective or what is the equivalent capacitance? So we can say these two capacitance are in parallel. These two are in parallel. So therefore I can write effective capacitance is equal to parallel combination of these two capacitors, which is 1 plus 1, which is equal to 2 microfarad. Therefore I can write effective capacitance of the combination across the points A and C is 2 microfarad. This is the answer. So what is the option given, or what is the answer? What is the optional answer? It is considered to be option B as the answer. B is the correct option. Clear? Okay. Let us go for the problem number 15. What is the problem number 15? A bigger problem, but a concept oriented. Come on, go through the problem. Two metallic spheres of radii 1 centimeter and 3 centimeter are given charges -1 into 10 power minus 2 coulomb and 5 into 10 to the power of minus 2 coulomb respectively. First of all, we will draw two metallic spheres. One of the metallic sphere is of smaller, this is question number 15, of smaller radius, that is 1 centimeter, and another sphere is of greater radius, and let us take this radius as 3 centimeter. They are given charges. So one of the charge, let us consider this as Q1, which is considered to be minus of 10 power minus 2 coulomb, and here the charge is Q2, and the charge Q2 is considered to be 5 into 10 to the power of minus 2 coulomb. Now these two are connected with a conducting wire. So these two spheres are joined with the help of a conducting wire. Now after that, the final charge on the bigger sphere is, so you are asked to calculate the final charge on second sphere, that is the bigger sphere. So final charge on the second sphere is Q2. Let us calculate what is the value of this Q2. See, as you know, when the two spheres are connected with the help of an small or with the help of a thin wire, then we can say the potentials are considered to be equal. First concept, the potentials are considered to be equal. If the potentials are considered to be equal, then we can also say sigma into R. That is, surface charge density is directly proportional to that of the 1 by R, or inversely proportional to radius, or directly proportional to curvature. Sigma R is equal to constant. We have proved. If sigma R is equal to constant, this one will be having sigma 1 R1 and this one will be having sigma 2 R2. Therefore, I can write sigma 1 R1 is equal to sigma 2 R2. What is sigma? Q by A. So I can write Q1 divided by A1 into R1 is equal to Q2 divided by A2 into R2. How I can simplify this? See, Q1 into R1 divided by, what is this A1? Area of a sphere, 4 pi R square, or 4 pi R1 square is equal to Q2 into R2 divided by 4 pi into R2 square. This 4 pi will get cancelled, this R1 will get cancelled, this R2 will get cancelled. So therefore I can write Q1 divided by R1 is equal to Q2 divided by R2. Am I correct? So let us take this. Q1 divided by R1 is equal to Q2 divided by R2. What else we have to go? See, let us simplify this. How we can? See, instead of this Q1 divided by R1 is equal to Q2 by R2, I know that when we are joining, the total charge available Q is equal to Q1 plus Q2. Therefore, how I can write Q1? Q1 is equal to capital Q minus Q2. From this relation, I can write Q1 is equal to, on cross multiplying, I get Q2 divided by R2 into R1. Take this and substitute it here. See, when you are taking this Q1 and substituting it here, what will be the answer? Instead of Q1, you will be getting Q minus Q2 is equal to Q2 divided by R2 into R1. So, I can write capital Q equal to, this I can write R1 divided by R2 into Q2 plus Q2. So, here I can take Q2 as common. I will be getting 1 plus R1 divided by R2, or I can write Q equal to, total charge Q equal to, how I can write total charge Q equal to Q2 into, see, 1 plus, if I am taking LCM, I will be getting R1 plus R2 by R2 is the capital Q. From this you calculate the value of Q2. What is the value of Q2? Simplify. What is the value of Q2? Therefore, Q2 is equal to, making cross multiplication, R2 divided by R1 plus R2. Multiply it with what? Multiplied it with the charge Q. Now you substitute what are the values. What is the total charge? See, total charge Q is equal to 1 into 10 power minus 2 plus, what is the next one given? The other charge given is 5 into 10 to the power of minus 2 plus 5 into 10 to the power of minus 2. So, as a whole, you will be getting, both the charges are positive? No, the first charge is negative. So, we can say the total charge is the additive nature, 4 into 10 to the power of minus 2 coulomb. Take this and substitute here. What is the value of Q2? What is R2? The R2 is given to be 3 centimeter. So, I can write 3 into 10 to the power of minus 2 divided by, what is R1? R1 is 1 centimeter plus, what is R2? 3 centimeter combined. So, I can take the 10 power minus 2 out, multiplied with the total charge. What is the total charge? 4 into 10 power minus 2. So, this will get cancelled. So, Q2 will be equal to 3 divided by 4, multiplied it with 4 into 10 to the power of minus 2. This 4 and this 4 will get cancelled, and you can get the answer as 3 into 10 power minus 2 coulomb is the new charge available in the system when the two spheres are joined with the help of an small or a thin wire. So, the option or the answer is Q2 equal to 3 into 10 power minus 2 coulomb. So, which one is the answer? The answer is considered to be option A. Hope you should have understood this. So, these are the two videos. This video as well as the previous video explains the different book back questions or the solution for all the 15 multiple choice questions available in your book. Hope you should have understood. Thank you.